video, we'll continue working with 6.4, factoring and solving polynomial functions. In our last video, we reviewed some of our old factoring friends. So, for example, in example 1a, we used our greatest common monomial friend, and then we used guess and check. In our second example here, b, we just were able to use our first friend of greatest common monomial. And in this example, C, we were able to use our friend factor by grouping. And then in addition to that, we were able to use our friend difference of two squares. And then we reviewed what it meant to solve after you factored. And basically that's looking for your x-intercepts or your solutions or your roots. Your first new friend is not actually too new of a friend. Friend 6 is going to be quadratic form. And the cool thing about this friend is that it's going to help you factor polynomials of a higher degree than 2, but you're going to factor it using the same methods that you did quadratics. So you can go back and you can use your first 5 friends. So what this friend does is if you have a polynomial function in the form au squared plus bu plus c, where u is any expression in x. So wouldn't that make sense if I plugged, for example, u equals x in? Then all I get is a, and then instead of u, I've got x, so I could have a x squared plus bx plus c. I got standard form of a quadratic all over again. But what if I let u be, let's say, x to the 4th? Well, now I plug that in and I get, if I plug x to the 4th in for u, raise that to the 2nd power, I get a x to the 8th plus b x to the 4th plus c. This is also going to be in quadratic form. Notice every term has a degree that's even, except for the constant, of course, that has a degree of 0. Okay, but the rest of the terms have an even degree. So you can use the quadratic form. All right, let's apply this. And I'll factor and solve. So for q of x, first of all, I notice that it is a trinomial, and I notice that all 3 terms have a greatest common monomial. So I'm going to factor q of x by first factoring out a greatest common monomial of, I believe, 4x squared. And what's left? I've got x to the 4th minus 5x squared plus 6. Okay, so the trinomial that is left can actually be thought of as a quadratic form, right? Where I have just made u an x squared, because x squared gives me x to the 4th. And notice this is u right here. All right, so I'm going to factor it using my quadratic methods, right? Let's see. I've already done the greatest common monomial. It's not a difference of 2 squares. Not a perfect square trinomial because 6 is not a perfect square. I think this is a guess and check. Lucky for me, a is equal to 1. So factoring this further, I'm going to use factors of 6 that I'll add or subtract to give me -5. Let's see here. My first terms have to multiply to give me x to the 4th. So I know that they both need to be x squared. Especially because when I multiply inners and outers, I better get an x squared. Now, factors of 6, I have a couple of options. I can use 1 and 6 or 2 and 3. This is complicated, but I think I'm going to go with 2 and 3. Let's see if I'm right. Again, I'm going to guess. I'm going to check. So I got a 2x squared. I got a 3x squared. Both of these would have to be negative to make it -5x squared. And if I do that, then my last term is positive, in fact. So that works out perfectly for me. All right, so now this is the factored form. It's time to solve it. So I'm going to take each of those factors and set them equal to 0. So let's see, I'll go 4x squared equals 0. Divide both sides by 4. I get x squared equals 0, or x equals 0. And in fact, this is going to be what we're going to call a double root. It behaves in a weird way. Okay, so I got an x equals 0 as one of my roots. I'm also going to take my next factor, x squared minus 2, set that equal to 0. So solving that, I'm going to have x squared equals 2. Take the square root of both sides. That's going to give me x equals positive or negative root 2. I don't know, that's approximately 1 point something. My last factor, I'm going to have x squared minus 3 equals 0. We'll add 3 to both sides. I'll get x squared equals 3. Same exact thing. I'm going to have x equals positive or negative root 3. Again, not sure exactly what that is, but it's somewhere between 1 and 2. So let's see, each of these will give me 2 roots, right? I got 2 roots there, and then I've got a double root. The fact that x squared equals 0 gives me a double root. So I've got 2 roots, 4 roots, 6 roots total, which makes total sense because the degree of this polynomial function is in fact 6, so I should have 6 roots. I also know that the end behavior is going to be same direction on both sides because it's an even degree polynomial function. And my a is 4, so it's positive, so it's going to be up on both the left and the right. Let's see if I can give you a rough graph of this. I'll do my best. I'll pretend like I know where root 2 and root 3 are. Let's see. Again, root 2 is somewhere a little bit close to 1. We'll just label it point or root 2. And then root 3 is going to be a little bit bigger, somewhere between, let's see, 1 and 2, because root 4 would be 2. So let's just put root 3 here. And then I'll do the same thing over here with a negative root 2 and a negative root 3. And then I got my 0 here. So, filling in my roots, understanding my end behavior, I know I'm going to be up on both left and right. So, and I'm not going to find all of my critical points, but I know I need to go something like this. And a double root means that you are a tangent. You never go through the graph. You come up, maybe go back down, and come through like that. So there would be an approximate graph of this polynomial, 6th root polynomial function. And that's quadratic form. Okay, you're just using your old friends in a new way. Friend 7, a sum of 2 cubes. Very simple. If you have the formula written out, this is going to be so easy. So notice that it's a sum of 2 cubes. Both bases are perfect cubes. And when you factor it, you straight up use this formula. I would have this on my cheat sheet. I wouldn't even try and memorize it. I would Google it. If you ever see a sum of 2 cubes and you can't remember how to factor it, you just Google it. And then you just use that formula right there. So the tricky part is figuring out what A and B are. So let's go forward with that. So the first thing you could do is you could figure out what the cube root, right, what the base is of each of these perfect cubes, just like I did with difference of 2 squares. So in this one, I could write this as x cubed. And then the question is 27 is what cubed? That's right, it's 3. So you see how this will be my A and this will be my B. Pretty straightforward. All right, so I'm just going to follow this pattern. All right, so I'm going to start with A plus B, and in this case, it'll be x plus 3. And then I'm going to move on to the trinomial part here. So it's going to be A squared, or in this case, it's x squared, minus A times B, or in this case, it'll be, I'll go B times A because it'll be 3x, plus, and then it'll be B squared, or 3 squared. Pretty darn simple. So we end up with x plus 3, and then x squared minus 3x plus 9. That's factored form. And if I want to solve this, I'm going to need, oh, let's see, I don't think I can factor out that trinomial. I think what I would need to do is the quadratic formula. Let's see, the first factor, though, is easily solved. So if set x plus 3 equal to 0, I get x equals -3 as one of my roots. All right, looking at the trinomial, let's see. If I wanted to use the quadratic formula, a would be 1, b would be -3, and c would be +9. Now, before I go forward with the quadratic formula, let me check my discriminant. Let me make sure that I wouldn't get any complex roots here. So that's just the part that's under the radical, b squared minus 4ac. All right, so I got -3 squared minus 4 times 1 times 9. So what I'm seeing is this is 9 minus 36. That's going to give me a negative number, and that tells me that I have imaginary solutions. So I have one real solution, and here I'm going to have two complex solutions. So you won't even see those if you were to graph this. Okay, so this is going to be a cubic, which means that my end behavior is opposite directions, my a is positive, and I only have one real root. So I am not 100% sure what this graph looks like, and I could spend a lot more time figuring it out by doing an input-output table, but I do know that I have this one negative root. I also know that I have a y-intercept. Let's pretend that that's 27. So maybe I don't really know what this looks like, but let's just pretend it looks something like that. I truly don't know. That's my y-intercept. And like I said, I could spend a lot more time, but right now, I understand the end behavior, I understand my root, I understand my y-intercept. Looks pretty good to me. All right, let's try this again. So on this one, let's make sure that we don't forget about our old friends. So I haven't even been talking about, greatest common monomial in the last example. I should have, but I didn't. So in this one, let's check in with greatest common monomial. He's usually pretty helpful. I can see that both of these terms have a common factor of 2. So I am going to factor out a 2, leaving me with 8x cubed plus 125. And lo and behold, both terms here are perfect cubes. So this binomial is a sum of 2 cubes. And if you don't know that, you got to recognize that 8 is actually a 2 cubed. So I can write 8x cubed as 2x cubed. And 125, well, guess what? That's just 5 cubed. All right, so now my a actually is a product of 2 factors, so it's going to be a little bit more tricky. And my b is 5. So now I'm going to just follow this formula, okay? A plus b. Let's see here. So I'm going to keep the 2. I'm going to do a plus b, which is 2x plus 5. All right, so now you're going to do a squared. So that's actually 2x squared. Be careful. Everything you plug in, put in parentheses. And then you do minus ab. So it's going to be minus, and I'll do b first. 5 times 2x. Okay, so those just got plugged into the formula. And then you're going to do b squared. So plus, and that's my b squared. Simplifying that, we're going to have 2 times 2x plus 5 times 4x squared minus 10x plus 25. Now, I wonder if I'm done here. It looks to me like my trinomial is a perfect square trinomial. I'm going to double check that. This looks like it could be written as 2x squared, and this could be 5 squared. However, if I were to multiply these together, I would get 10x, and if I were to double it, I wouldn't get this. Okay, so I think I'm done factoring. Now I'm going to solve it. So I'm going to take each factor, set them equal to 0. So I got a 2x plus 5 that gets set equal to 0, and solved. So x is negative 2.5. And then I think I'm going to do the same thing, and I'm going to double check this trinomial before I start doing the whole quadratic formula. So I'm going to double check my discriminant, the b squared minus 4ac. Let's see. A is equal to 4. B is negative 10. And C is 25. So if I do the discriminant, I get negative 10 squared minus 4 times 4 times 25. So I think this ends up giving me 100 minus, well, let's see, 25 times 4 is 100 times 4 is another 400. So that's going to result in two complex solutions. You won't be able to see those on a graph. So my only real solution is x equals 2.5. And I'm not going to graph this. It's going to look very similar to our last graph, but it's got a y-intercept at 250. All right, so factored form is going to look like this. And then the only real solution is x equals 2.5. And your last friend, difference of two cubes. Actually, a super easy friend now that you've already met the sum of two cubes. It's the exact same formula. The only difference is the subtraction sign has moved. It used to be a subtraction here for a sum of two cubes, and it was a plus here. Okay, so this is a sum. That's the only difference. Okay, they've just changed where these signs are. They just kind of switched them around. So if you look at this problem here, you ask yourself, well, first of all, is there a greatest common monomial? No. I noticed that the first term is a cube, right? It's something cubed. So I wonder if the second term is as well. And as a matter of fact, it is. 4 cubed will give you 64. So this is minus 4 cubed. So x is my A and 4 is my B. So I'm just going to follow that pattern for factoring. So g of x, let's see, I'm going to have A minus B. So we'll go x minus 4. And then following the pattern, we'll have an x squared plus A times B. I'm going to go 4 times x, so B times A. And then plus B squared. And B is 4, so that is 16. And you might want to double check, hey, can this second trinomial be factored again? I don't believe that there are factors of 16 that'll give us 4. So I think we are completely factored. And now we'll go ahead and solve. So I'll take my binomial factor, set that one equal to 0. Awesome, x equals 4. That's definitely a real root. And then I can double check this trinomial before I get crazy with the quadratic formula using the discriminant. So A is 1, B is 4, and C is 16. Well, guess what's going to happen? So when I do B squared, it's going to be 4 squared minus 4 times 1 times 16. I'm going to have 16 minus 64. That's negative, so I have 2 complex zeros again. So those won't show up on our graph. And again, it's a cubic. You've got a y-intercept of negative 64. It's going to look a lot like the last one. And because I'm out of room, I'm not going to do it. All right, so there's your new friends. You got 3 new friends that you can add to your friendship group with all your other factoring friends.